Somebody say something. No, not you guys. Somebody online. I guess I got to admit him first, huh? Oh, so far 6 and 6. Oh, there's the 7th I was going to say. Oh, getting a little bit of feedback. Okay. I guess the consensus was to default to saying I'm going to be online. Which isn't a bad thing necessarily. I think I saw a microphone. Yeah, I see a microphone bouncing somewhere. So, okay. And I guess at some point I could have said, let's all just go all online. But all right. Either way. My bad for not over communicating again. My apologies, but thank you for joining. I guess at some point. All right. So at 10:33, I'm not going to say, is that everybody? You know what? At this point, I want to do that at least. Here yet. That's 22. Jeez. 22 plus 6 minus 1 is still a couple short. All right, whatever. You gotta get going. Hi, how y'all doing? Do I have somebody out there that wants to at least say a word to see if this thing is working on a...
It's working.
Yay, okay. You don't need me to put on a video feed or anything, do you? You got the screen share?
Yeah.
You're good on our end.
And that shows up that way. And because again, I recognize that actually it was Friday last week. It was this time last week. And wasn't it you guys that were online that you didn't see the presentation, you just saw the camera? Yeah, my apologies.
Yeah, yeah, that would be it. Yeah, I think that was about then.
Yay, all right. Let's see. Okay. I'm actually going to bounce out of that anyways because I just want to see this way for the moment. All right, a couple things looking ahead, by the way, just so you ground yourself at the end of week 2, to say that, yeah, it's the end of week 2. It's normally around the end of week 1. We're a little bit early and all that kind of stuff. So that's meaningless to you because this is your first year. My son went back to school yesterday for middle school kind of thing, so they're on their regular schedule and all that kind of stuff. But yeah, no, for some of us, it is kind of a little disconcerting and we're trying to just, adjust ourselves to this idea. I was joking with some of the upperclassmen because normally it's the end of the first week and then they got Labor Day and a day off, and we always joke, what, you have your first week and all of a sudden you need a day off already kind of thing. And obviously we're going straight through. So not a big deal, but what is a big deal is that I haven't exactly given you much in the way of tasks, of assignments, of grading, of like actual work. I returned back at least the History Channel questions to everybody that had submitted them, which was everybody, which was still phenomenal and earth-shattering and unbelievable. But I haven't asked much else of you so far. There's going to be a couple of questions that just get thrown your way as take-home kind of stuff. And again, nothing huge, nothing as a great, test exam kind of anything that you need to be stressed out over or cause you much anxiety. As I've said in the past, you'll get used to hearing this phrase from me, a series of questions that affords you the opportunity to convince me you know what you're talking about. Okay. I'm trying to debate whether or not I should just get those to you this afternoon or not. It's kind of that kind of thing. I don't know yet. I'm thinking that I might get them to you this afternoon as a take-home assignment that is due something around Wednesday, before class on Wednesday, kind of thing. That way, if you do have time on your hands over the weekend, you got time on your hands over the weekend, and you can manage your time that way. As I've mentioned, part of 102 is the idea that you get to get enough rope to hang yourself with. In other words, I afford you the opportunity not just to convince me you know what you're talking about, but enough opportunity to actually, how do I say, forget. And, to say, hey, I know that this was assigned, but it's not due yet. I'm going to put it off. I'm going to put it off. I'm going to put it off. And then you come into class one day and I pull up something like saying, hey, there was 25 out of 34 that turned it in. You're like, oh, crap. Yeah, I put it off and put it off and put it off and completely forgot about it. So in other words, I got maybe about 7 questions I want to ask you. And out of those 7 questions, maybe about 4 of them are things that we've talked about in class already. That'll be your, again, opportunity to put it in your own words kind of thing. The other ones are not things that we've really beat to a dead horse, like a dead horse, to a pulp, like, all those mixed metaphors, but are easily accessible kind of questions that you can either Google or get from the first chapter of the book. And they are, in the terms of take-home assignments, low-hanging fruit of recognition that these things exist, and I've at least asked you a question at some point in your life about them, right? So that kind of thing. So in other words, I feel like they're fair game and that anybody should be able to get an answer to them at some level. So yeah, probably this afternoon I'll post that, but it won't be due until Wednesday. Okay, so don't consider it a test. Don't consider it a earth-shattering, anxiety-driving kind of assignment, other than the fact that I need to get some sense of how you answer things in full sentences, and give you some feedback so you know where you stand and get some idea that, as a first semester freshman, yeah, I can do this quality of work, which I'm sure you all can if you actually decide to do it. But I know some of you are trying to figure out what that balance is of what is college level work as opposed to what's 7th grade work. It's amazing that in the beginning of a first semester freshman life, there are those people that try and bounce between that extreme of overdoing it and completely underdoing it. And there's not many people that submit like 11th or 12th grade work. Most of them are either right there spot on, or they're way under shooting what they need to put in. But you don't know until I ask you to do something, which is why I'll ask you to do something at the end of week 2 here. Okay, sorry about that. But I think everybody, okay, so nobody's waiting. Where we left off, and I only got a couple things today. Obviously going to the end of this, and that's about it. Hardware, software, the experience, and I rushed through it so I could get to the idea of bringing the machine to life. I want to talk about that. I want to bring up, again, overstress the difference between an operating system and applications and what this specific real importance of the operating system is. But then a real quick run through what the hierarchy is within the language and interpretation kind of path is of how you have an application running and gets all the resources it needs, and that kind of nesting doll, once again, atmosphere of layers of the computing system that it kind of has to interpret all the way down. So yeah, I don't have to really, again, belabor the hardware idea. Yeah, hard drives, network cards, RAM, motherboards, chipset, the actual connectors. And again, we won't belabor that, but there will be a couple of things in the near future next week where, there is a small little, okay, here's a breakout of like, what a motherboard is, what's a bus, and things like that. So, hardware, normally things you can pick up hard. right? Although virtual machines, we need to represent those virtually somehow as well. Software, obviously, code. The instruction set of what that hardware is supposed to do. Operating systems versus applications. The operating system, as I brought up earlier on Wednesday, the primary absolute function of the operating system is to maintain the system, to keep the system alive, to provide the platform that is going to allow you to run other programs, other applications. So it's your interface to be able to control the hardware, but the primary task of the operating system really is to maintain the life, the actual uptime, the availability of those resources, and manage them between the running applications and your commands that you're issuing to it. Is the operating system an application? Yeah, absolutely. Is it a single application? No, it's a series of different running applications that all work together to create that platform, if you will. All right. It is a very special application because it does have that, how do I say, command and control kind of feel that gives you the opportunity to control the hardware. Okay. But at the end of the day, and the example I used verbally to you guys on Wednesday was, if you're one of those, nature loving people that end up, off in the wild of Alaska and you end up in, a blizzard and you're stuck and you're going to die of hypothermia. You don't die of hypothermia all at once. That body tends to kind of conserve stuff to protect the body first. It's okay if you lose a couple digits. It's okay if you lose an arm, as long as the rest of the core of your body is going to be able to function. Same thing with an operating system. If you have, several different tabs open in Chrome, if you have, some other game running in the background, if you have some other streaming video running in the background, if you have if you have a bunch of applications running, it'll slow those down first so that it can execute and maintain what is keeping the operating system alive for the computer. That takes priority as processes. Okay. Just to reiterate this one, because it's not in the book. And if you look this up, it's one of those things that, you'll get a couple mixed messages out there. But if you adhere to this one, and if you pay attention and you listen and you say, okay, this is one of those spots, rarely do I ask you to memorize something I give you. Rarely do I say, hey, listen, this is mine. You need to memorize this. This ain't mine. But if you've ever been, and there are a couple people in this class that have put together their own computer. If you've ever been somebody that's, built a system, you'll know that this, whoever's name we want to put to this in general, this is the path that you're going to take. Okay. There might be a couple other labels with bootstrap, if you will, but that's why I put it in quotations. Post is universal though. It really doesn't matter what the hardware manufacturer of the motherboard is or the chipset is. You are dealing with an inanimate object. I can't stress that enough. It's an unthinking, unknowing, non-sentient being. We personify it all the time, and we expect things out of it because we've grown up personifying it and talking to them and asking them things and telling them to do things and all that kind of stuff. And for the most part, they do, even though they're unthinking, non-sentient, inanimate objects. It's amazing that way. It's absolutely phenomenal, right? But at the end of the day, you got to turn it on. And when you turn it on, it's not like waking up for you getting out of bed and you got a brain and a mind that just knows things, right? We must provide everything to that box so that it can begin to function. And the very first piece is the power on system test. Okay. Very little to no code here. Just a recognition that all the pieces are there. That there is RAM, there is a motherboard, there is a processor. If this fails, you probably will not see anything on the screen even, because it hasn't even been able to get enough instruction to actually know how to put something on the screen. It might not even have gotten far enough to recognize that there's a video card or anything attached to it that it has as that output. The most basic form of output it has is either a blinking power light or a beeping system speaker. So you talk about beep codes or blink codes, because that is the most base level that we're talking about of the ability to communicate is almost none. Okay. It does not have the physical capability to go farther. It can't even begin to load an operating system. It's not even really beginning to load the BIOS. Okay. Something physically is broken or missing or wrong. That's the power on system test. Once we get past that, we need to be able to talk to the components and actually start to move things around. And that's the BIOS, the basic input-output system. That is unique to the chipset, and that is unique to the manufacturer of the hardware. So this is not Windows yet, and this is not a Mac yet, or Mac OS Catalina or whatever we're talking about, right? This is just simply the Intel Inside. This is why you get the boom or whatever sound that you're going to get, okay? It is the simple beginning drivers that tells the processor how to start to read off the hard drive, how to start to place some instructions into RAM. What is the next step in starting to get started? Once again, this isn't, if you've ever, gone to a foreign country and doesn't speak the language, at some point or another, you're going to have to learn the basics to begin to read, to begin to have a transaction. This provides a simple hardware description of how these components start to, well, communicate with each other. If you have a bad video card or a bad video driver, right, there's a default low level, just plain old VGA with maybe 16 colors. So you don't get the wonderful smoothing, you don't get the wonderful, just spectrum. It's very basic, it's very blocky, it's, a default resolution that is, out of sync. It's not just nice looking because it's really rough and rudimentary and basic. Because you're still dealing with the default BIOS video driver instead of a more complicated, more specific driver that's later on in the operating system, right? It's fallen back to the safety net. So really simple, basic instructions, enough so that now the components, we don't just recognize that they're there, but they can start to interact with each other. And again, on these, if you turn on a desktop in here, you get the Dell splash screen. If you have an Asus or some other Lenovo or an HP, this is now the manufacturer's splash screen that says this is this computer. When we get to the bootstrap, and you see that there is a mass storage device that has an operating system on it, most likely your hard drive. It will start to load the base of that operating system. There is a process by which that happens. Again, the operating system is not a single application that's running, it's multiple different pieces. In a lot of desktops and older style computers, yes, this is where you see the multitude of black and white lines getting executed before you get to the graphical user interface or the desktop. If you have any experience in Linux distributions, yeah, this is still very common to see that string of commands running and then boom, here we go to a desktop. Macs, it might be hidden behind, a gray screen with an Apple on it or something like that. Windows now is starting to hide more of that behind, the window with the little circle underneath the little window symbol. Right, but that's still going on. That is still the process of getting from, not even reading off the hard drive to that spot where you then take control. and you have the ability to issue commands. That's where we get to the operating system. It's loaded, you're on the desktop, you have the point and click, maybe not. Maybe you do have a command line interface, maybe, I don't know. But this is where you now have the ability to run a different application, to interact with the operating system, okay? You have a platform of usability. Now the separate applications, again, we have to recognize they're separate. They're individual, they're independent of the operating system, okay? And you can't expect them to be there. I hate to say it that way, but there are certain things that you expect to be there, and there are certain things that you have to provide. You know, and again, moving from consumer to a more advanced user, most of the time, and I hate to say it this way, but you probably still in that case where most of the systems that you have used or interacted with have been provided to you as opposed to ones that you've configured yourself. As I said, now I do know there is some people that have had that experience of building their own. But once again, this is one of those things. There was a time, where you had to build your computer. Some assembly required. Somewhere in the mid 90s, in the 95 through 97, 98 range. You have more Windows 95 computers. You have Dell show up. You have Compaq show up. You have Gateway show up as manufacturers that, well, you want a computer? You buy a computer. It shows up on your doorstep in a box. You open that box, you take another box out. You put that box on your desk and plug it in, and guess what? It works. It has come to that kind of an interchangeable consumer device that is the black box. Not as many people have to get under the hood and do anything with it. If something breaks, what happens? Well, you get another box. In the corporate world, if something breaks, maybe they send a repair guy out. We used to have different cards all over the place of a network card, a video card, and you can still do that as a person that's a hobbyist that wants a better video card or something like that. But in the corporate world, they're on board, on the motherboard, soldered on. So, used to be if a network card went bad, you got another network card. You popped it into a slot on the motherboard, and that was it. Off you go. Now, okay, just replace the whole motherboard. No, just replace the whole box and get a new box. So that component-driven kind of mentality is such that, yeah, most people don't have to deal with the idea of providing, the extras anymore. They're just there. But you have to recognize that. All right. The new stuff for today. And not that it's new, but there are about 3 different layers of how these signals and commands go through the system and actually get executed. Now, there's a brief overview, and again, there are going to be classes that you have to take for computer architecture and operating system. I'll go much more in depth on this, okay? But at a base level, at an intro level for 102, yeah, eventually, and we're going to go from, farthest in and then back out. So maybe that's reverse of what you're thinking, but okay, we'll start at the CPU itself. Once again, it's a machine. Once again, it's circuits. Once again, it's electricity. So we talk about binary language all the time. And sure, most of you would probably say at the base level, what are we doing with ones and zeros? No. At the real base level, we're dealing with 5 volts or 0 volts. At the most base level, it's an electrical signal that has to go through this circuit. All right? And that's real. And again, as we talk next week about a couple more hardware components, there's a reason why there are fans and heat sinks. What happens when you push a bunch of electricity through a toaster? It heats up, right? So at the base level with your phone, with your laptop, with a desktop, whatever computer it is, there is electricity that is flowing through a circuit through that CPU that's going to heat up. So how are these commands actually executed? Well, by pushing electricity. 5 volt or 0 volt. How do you define at the end absolute point what is a 1 and what is a 0? Doesn't know what a 1 or a 0 it is. It knows that, okay, I got electricity, I don't have electricity. Great, okay? So slightly more complicated than that, but for the base, let's understand that electrical signal first. What does that electrical signal represent? 1 or a 0. What is 1 or a 0? We're starting to talk about machine level language. There are only very simple commands that are issued to the processor. And as we get up to low-level assembly language, we are talking originally only 82 commands that end up going to the processor. Okay. Now, they are represented, as a series of 1s and 0s. So you can understand that there's only so much that you can do. But I say this in 110 all the time. Okay, how many primary structures are there in programmings? Really 3. Hate to say it that way, but the 3 primary structures in programming is, what's the next step? Straight ahead, linear. How many times do I do this? There's loops, right, as a structure. And then what do we got? A decision. At any one point, do I go down this path or that point? Right? So we got a branch. So you got a loop, you got a branch, and you got a linear next step. 3 basic structures, that's it. How many primary colors are there? 3, right? How many colors do we get out of 3 primary colors? Trick question. As many as you need. Right? I mean, whether it's that billions and billions served in a McDonald's sign, or whether it's just as many as you need with however many shades go in the spectrum. So how many different programs can you build out of 3 different basic structures in a program language? As many as you need. That's the trick question, right? It's how you build them together, how you chain them together. So if you got as many as you need out of 3 options, wow, you got 82 basic commands that you can send to a processor? Wow. Okay. Yeah, you can do a lot with that. Right? So machine language, again, going up. Oh, yeah, bit. 1 or a 0. 1 piece, 1 representation of data is the bit. Okay, that'll be in the next chapter. We actually have you read in the book. All right, so don't want to belabor that just yet. The next level up, low level, assembly language. Okay, it's a kind of a go-between because you got to have some interpretation or some middle ground between our natural language that we are going to code in and what that 1-0 machine level representation of electricity going through a circuit is. It is the interpretation of chaining together, and as I mentioned here, the 82 instructions of what you're trying to have it do. In that broad sense, in that imaginative brain of your free thinking as a human, what you want to do. And you describe that. This assembly language and low-level language takes that really high definition picture that you have that is just broad and then breaks it down into how do I accomplish that with this dictionary of instructions that I can issue to that processing unit. It is your translator. And then when we get to your piece, high-level languages. All right. Machine code 1-0. Machine code voltage. Assembly low-level language. You have a character set that looks like your alphabet. It looks like commands that say fetch, all right, or hold, or something like that. Very simple words, but a limited set of words from which to choose from, with a preset definition and a meaning that you can't change. When you get to the high-level language in your language, This is where we get to object-oriented languages. This is where we get to C++. This is where we get to Java. This is where we get to C#. This is where we get to your ability to create in character sets, in words, in basic language that you understand. This is where you as a programmer do most of your work. As a machine engineer, as somebody that is going to be a hardware developer, you will do a little bit of work in assembly language. If you are going to be a hardcore developer that is going to be working direct on operating systems and other kinds of, that interface between the code and the hardware, you will do some work in assembly language. Only really electrical engineers and not really computer scientists or programmers or software developers or software engineers do any work on actual machine languages and the voltages and the ones and the zeros. That's electrical engineering. That's not really our world, right? Assembly language could be your world, but a very narrow area of our world, okay? Most of you are going to end up in the software development area. That will be in the high-level, object-oriented, natural language programming area, right? And there's obviously a lot of flexibility there. And there is the ability to, well, create your own words, create your own dictionary with a full character set that then you will recognize and understand. And again, if you pick up other ones, you get to grammar, you get to syntax, and you get to some basic combinations that, are somewhat universal across. Once you know one language, it's easier to pick up another language, right? You know that some of them are a little bit easier with words that you recognize like print. Or, well, you very quickly become familiar with other words like see out, right? So, all right. There is a stack of how that gets interpreted, sorry. And this is straight from our book, where you get the machine language, the assembly language, the high-level languages, the system software, and the application packages. But what I want to stress is this figure from a different book, okay? Because this is more important to kind of the real flow and some of the questions I'm going to ask, like I mentioned about you going to look a couple of these things up to hammer this home a little bit. What really happens here is you got a program you want to run, even if it's something as simple as a web browser like Chrome. Okay, you fire up that web browser like Chrome, and it has an executable that's written in a specific high-level language. That specific high-level language will have to reference different libraries that are within the operating system so it can understand what those are. When I mentioned already about C++, and you're far enough along that you've done a Hello World program already in 110, right? Right? Yes? No? You've done it. You've at least compiled something.
Yes.
So when I said C out, you probably know what C out means. One of the beautiful things about that high-level language is that something like C out does a lot of the heavy lifting for you already. You, as somebody that's a programmer, you don't have to worry about writing lines of code and instructions that light that pixel, right? You don't have to worry about when you want to print the letter P to the screen that you identify the exact coordinates and the exact location and, as I said, light each individual pixel for that P. There are libraries within the operating system. There are libraries associated with C++ as a language that says, if I see that command as a C++ program, I am going to interpret that command based on these libraries that I already have installed in my operating system. And I will understand that C out says this. And I am going to print that letter or whatever is within the quotation marks or whatever the data that's coming from the result of this calculation is to the screen this way. And if I am going to light pixels, what happens? I got to talk to the screen. And if I'm going to talk to the screen, I have to talk to a video card. And if I'm going to talk to the video card, I'm going to have to go through the motherboard and have to understand how that video card is recognizing the command to light that pixel. Different pieces of hardware have driver files. Hardware driver files. If you have a printer that is a regular printer, they come with an installation disk that says, here are the instructions on how that operating system is going to talk to this piece of hardware. If you do have to install a different video card or a special video card for gaming or a cryptocurrency rig or whatever you're doing with an extra video card, there's another driver file, a set of instructions on how to talk to that video card. If you have a different wireless network card, or if you have a different network card that you want to put in, there is a different driver file from the manufacturer of that hardware that gives instructions for the operating system to know how to talk to that piece of hardware. They don't automatically work. We've taken it for granted that plug and play, which is an ancient word, and again, it's like, revisiting Windows 95 how many years later, right? Yeah. That was one of the miracles of Windows 95, was this idea that there was a assumption there were default drivers that could be semi-universal, and there would be an expectation if you plugged something in, there would be driver files that the operating system would know how to talk to that piece of hardware. Okay. Then you get to, the operating system that has its general interpretation of how to manage this executable, how to talk to the processing unit, how to put the instructions into memory so that it can work with it and manage it in conjunction with all of the other instructions it's getting from everything else that's going on with this multitasking, multi-use computer. That puts it into the assembly language. And that assembly language eventually gets it down to the machine language in the 1 and the 0 that actually goes through the circuitry. Okay. So in this, we have the hardware. And again, we have this little arrow. If you're not really paying attention to the entire picture, I know it's easy to lose this arrow over on this side, right? But complexity, and the complexity goes up as you get closer to your interface with it. At the bottom, you have hardware. Not very complex. Electrical impulses, right? Then you got the kernel, and the kernel being the core of the operating system. That is doing the assembly and doing the interpreting and accessing these libraries, whether it's the library from the language, C++, Java, whatever it's going to be, the drivers for the specific piece of hardware that it needs to talk to that work in conjunction with the operating system. Okay. You got other runtime libraries and things that come with your program if it's an installed program. Right? Not necessarily hardware drivers, but if you are programming in a very complex object-oriented way, you're going to create your own libraries. And that's more above the kernel. You don't expect those to be there, but you're going to provide them later. Right? And that's at the higher end of software development. Then you got the frameworks that happen within the operating system. If you are going to, I don't know, have sound, right? Then there are subroutines, and I've mentioned the operating system is more than one thing. There are subroutines that are already written, subprograms that are already there within the operating system of how to play music. Can I access another program? Can I invoke another video player or something to that effect? And then the application itself, the web browser. So as you get to the top of this is the most complex. You managing it, you directing it, and as you manage and direct it then, do I have to work with any other programs, any other applications that are already here? Am I invoking them? Am I working with them? Am I providing any other very customized libraries that are specific to my application? Am I accessing any other of the instruction sets that are unique to a piece of hardware? Am I accessing libraries that are unique to an expected language interpreter like C++ or Java? And is this then doing the assembly to issue all of that together down to the hardware in terms of 1s and 0s and 5 volt, 0 volt? That is a really high level flow through this. That is a really simplified kind of way of looking at it. But as I said, just getting the idea of the system working together, okay, of interacting with different components, of recognizing that this isn't always there and you might have to provide it. This isn't always there. You might have to provide it. These other things aren't there. Maybe you have to go install another component. Okay. From the most part, as I mentioned, no offense, but from a consumer standpoint, in your experience, for the most part, most of this has already been there. And if it isn't, you got to stop dead in your tracks because maybe you don't even have administrative privileges on the computer to be able to reinstall something or to get one of those extra components there. But now you will. Okay, so introduction to that. And let's see, platform independence. Last thing, I got 7 minutes, and this really is kind of the last thing. We talk about the different operating systems, and we mention, you got your Windows, you got your Mac, and most of you will recognize you got Linux. I don't normally have to go too deep anymore. This actually used to be heavy lifting years ago. That there was a Mac and there was a Windows and that was it, and you were there. But now, obviously, with phones, there is this recognition that, Android's there. Oh, yeah, wow. It used to be that you were so dead set in the one device and the one operating system that it was like kind of, well, as I said, once you know one programming language, it's easier to know other programming languages. Once you know one operating system and you've had to bounce to a different operating system, okay, your expectations are, I have to adjust. I can't expect them all to be the same. So it's gotten a little easier to get you guys to buy into the idea that I can use more than one thing, nowadays. And that's good. That's really good. Okay. But one thing that is still unique and still a problem, and we've gotten somewhat better, but it's still kind of a holy grail, is the real platform independence of different applications to be able to be universal to all of the different operating systems. And obviously, there is Microsoft Office for the Mac, right? But there are still some things that just don't translate, that just don't work on other operating systems. You will not find Microsoft Access, even though you can do Word and Excel and PowerPoint on the Mac, you can't do Microsoft Access, which is a personal database program. There's no port over to the Mac. Only recently has there been a port of Visual Studio to the Mac, right? It just, only recently. And now, even with Visual Studio for the Mac, I don't know how many of you are trying to get through 110 with a Mac. It really sucks. Because even though there's Visual Studio for the Mac, yeah, it likes to program in C#, not C++, which is actually fascinating because most of the underlying code in a Mac is actually interpreted as C++, which is, kind of fascinating. But either way, even then it's kind of hard. There is a platform dependence on the underlying languages that platform understands and recognizes. And natively, they're not all there. And that is why you can't just pick up a Windows executable application and expect it to go run on a Mac platform. The libraries and the expected subroutines and the drivers of how to interact with the different pieces of hardware are different. And they will not be there as the support material for the running executable of the application. Or you have to have them customizable so that they do work with the libraries that are there. Non-denominational platform independent languages are, well, like I said, trying to be a holy grail at some point. Java was hoping to be that. And to a certain degree, it kind of is. But to a certain degree, here's the problem. You assume Java's there. It isn't. Java doesn't come inherent to the operating systems. You got to put it there. You kind of assume it is because most of the time it is already from somebody else that was there before you. But if you've ever had a flat base install, if you've ever had the bare metal kind of bring it up from scratch, you'll know that, sometimes when you get to the first web page that has a script, it will say, hey, you don't have this. You need to go install it. Hey, you don't have the latest version of Java. Why don't you go install it? You know, that demands a little bit of extra work from the consumer and the end user. As I said, we've evolved to the point where it's pretty seamless and pretty easy. But here's the other problem. From the cybersecurity standpoint, anything that you add on extra later becomes an attack point. And this is where most vulnerabilities really do occur within the operating systems, is where those third-party add-ons come in. Which is why when, say, Apple decides, hey, we're going to phase out Flash, and we're going to say that past this certain date, we will no longer allow anything that has Flash to run within our operating system. There's a lot of people up in arms because Adobe Flash was one of these options or one of these ideas of a third-party platform independent interpreter of code. And for a while it was okay, but you're relying then on Adobe, and then you're relying on the different operating systems to continue to maintain the security and the updating and the code of those add-ons. And as I said, it's a very big focus point of attacks. So it became the primary attack vector for all the Macs. And what does Apple eventually say they have to do is to say, to protect ourselves, to protect our reputation, and to protect our users, we're just going to not use it anymore. And we're just going to block it from being executed within our operating system. And they have every right to do that because, well, they have every right to protect themselves and you as Mac users. But again, it shows the vulnerabilities of third-party, multi-platform, non-denominational interpreters. So it's still kind of a holy grail. HTML5 as a standard is kind of getting there because, again, we'll get into HTML later, but as a primary markup language, it was not very dynamic. It didn't really execute things other than how to lay out and display stuff. But with HTML5 as a standard, HTML started to branch into that void left by Flash not being there anymore, of how to execute some more dynamic code as opposed to just layout and design. Okay, so is that going to be it? No. Last thing. All right. So yeah, don't forget, PC stands for personal computer. I kind of said this once before, so this will be a quick repetition. At the end of the day, PC stands for personal computer. It does not stand for Windows. And again, when you get into history and evolution of what the original creation story is for different manufacturers, if anything, an Apple computer is more of a personal computer than anything else. Right? You know, your Windows machine was designed to be a corporate networked sharing device. Your MacBook was meant for you as an individual, as a creator. The communications and networking and sharing were all secondary in the creation of that. Really, think about it, okay? There's no real good Apple server operating system. They've tried a couple of times, but every time they've tried, it's failed miserably, and they do not have an active operating system that's considered a server. Whereas Windows Server has basically a monopoly on the server market in the corporate world. So personal computer means that it's used by you, end user device. Who's the audience for it? Right? Don't get mixed up with marketing. Think of end use and what's actually happening with it. Okay? And I hate to say this, but again, we get different global stats, and I need to update these, but there are some. Where's the latest one? I know there's some more recent than this, but market share, December of 18. To put it bluntly, Apple's never really gone over 17% of the PC market share. They've never really gone over that. And now that market share is even more shredded and, as I said, scattered with much more Linux adoption, although even Linux adoption is, how do I say, very niche and very specific as well. Windows does not have a monopoly. And I want you to understand that as you go through your career here, you will probably touch everything. Whether it be Macs, whether it be Android, whether it be Windows, whether it be Linux. Okay. You will have opportunities and you will have classes that will touch them all. You need, as a developer and as a systems designer, to recognize what's best for the situation, what's best for the need. And you can't live in one camp or another. It's as simple as that. Okay. So with that, I'm 2 minutes late. Sorry. But again, I will post some questions before I leave today for the weekend. They will be short. They will be sweet. I'm expecting like short paragraph answers of the 4 to 5 sentence nature. Let's have more than one sentence thoughts. Okay, but it doesn't have to be elaborated upon as a page each or anything like that. These are short answer, short response kind of questions. Okay, so it'll give you an opportunity to see where you're at and get like some idea of what I'm expecting in your responses. And it'll give us a little bit of a break point before we move next week into a couple of the chapters in the book and then move forward with algorithms and flow charting and things like that too. Okay, have a good weekend. Belgian Grand Prix, Spa-Francorchamps. Formula One? Yes? No? No? Come on. It's one of the grand old tracks. Eau Rouge. Yeah? No? Please, check it out. Anyways, I got to run. I got to see if Lucarello Lecture Hall is actually open or not. So, okay, in the chat, again, is there supposed to be audio? Yeah, I hear him. Good. I don't hear anything. I'm a rejoin. I'm a rejoin. That's what I like to hear. All right. Oh, you crazy kids in your lingo. I can't get away with that, can I? No, I'm a rejoin. All right. No. All right. Turn it off and turn it on. Yes. Do a wonderful reset. All right, guys, don't have the video, but I am going to end now that I saw the thing. I guess I didn't miss much. So have a good weekend. Be attentive to Schoology, and I will be posting something later on this afternoon. Take it easy. Bye.